Hey, how's it going? This is Mr. Hernandez, and I did want to go over this Desmos activity. Roots right now will be the same as x-intercepts. They're going to be synonyms. And so it talks about, basically having two x-intercepts, which these all do. This one, however, I would drag this one down so that the two x-intercepts are around these two dots that they give you. And so, other than that, here's another example. Now, this has an x-intercept where it tells you on this side, but this one is too far to the right, so you want to move it over here. So now it has the two x-intercepts where it wants it. But okay, so after this one, it talks about this here. X minus 2 is, and then x minus 6 being the factors of these x-intercepts. And so somebody wrote there the opposite. If the x-intercept is 6, then you're going to have a factor of x minus 6. Let me see. So this is, it's just flipped. Okay, so the sign is different. Everything, the parenthesis, what the number that is in the parentheses is the same as the x-intercepts, maybe just a different sign, huh? Okay, so here's one where you're going to use what you know about that and create the factors. So in this case, you have a x-intercept of 4 and 7 right here, and so positive 4 and positive 7. So the factors would be x minus 4, x minus 7. So this student did get the x minus 7. Which did go through this x-intercept, but then you need the other one to be x minus 4, and that way you will have both of them. So yes, like that. So again, well, it looks like most students got it. This one, you put x plus 4, x plus 7, but because the x-intercepts are positive, you want to make these negative. It's always the opposite sign in terms of the x-intercept and the factors. So that's how you get it to match. Okay, so now you have a positive and a negative. So in this case, you have a negative 3 and a positive 2. So if you flip it, that's going to be x plus 3 to go with the negative 3. And the factor for the factor x minus 2 goes with the x-intercept of positive 2. So again, the sign switches. So this student put the factor, the x-intercepts here, but then remember to put the x, and that's how you get the correct factors. Now, technically, it's x minus the negative 3, and then x minus the positive 2. If you want to write it that way, I believe you still get it right. Yeah. So that's just, the whole opposite thing is just about there's already a negative in the factor. So if you throw in the negative x-intercept, it'll be x plus 3. And the same thing with the positive. If you put the x minus and then the positive 2, it'll be x minus 2. So that's what that is. This student almost got it. You just need to put the x's, and that should be good. Actually, this should be x minus a negative 3, or x plus 3 would be good too. Okay, so good. Most students got that. All right. This one was both negative, but notice that it missed the negative 3. So this should be x plus 3, and that should fix that. Okay, so let's just move on to the next one. This is 3 factors. I'm really, really impressed. A lot of students got these 3 factors. Let's see what's going on with this one here. So this student listed the x-intercepts, but remember to put them in factored form. So you need the x with every single one of these x-intercepts. And not only the x, but you got to switch the sign. So for the positive 2, that'll be x minus 2. For the negative 2, that'll be x minus a negative 2, or x plus 2. And then for the positive 6, you need the x minus 6. And that should get you your polynomial going through each one of those x-intercepts. And so again, factors, x-intercepts, right now we're using them interchangeably. So this student looks like they missed the x minus 2. So if you make one of these x plus 2, then you'll get the negative 2 there. Okay, so let's move on to the next one. Is it possible to move a so that it only has 2 roots? So that really means 2 x-intercepts, right? So here you have it looks like it still has 2. There's 1. See, there's 1, 2, 2 x-intercepts. If the way it was a little bit too high, like this. See, there's 1, 2, 3 x-intercepts. But yeah, it is possible to have 2. So this student did get 2 x-intercepts, or 2 roots, right? This has 3 x-intercepts, so you got to move a down, or there's 2 x-intercepts right there, or 2 roots. You could also move it up, right there. 1, 2 x-intercepts or 2 roots. So I do see this student got it. This student got it. This is 3 x-intercepts or 3 roots. This is good. This is 3. This is 3. This is good. This is good too. So yeah, it is possible to only have 2 roots or x-intercepts. Now what you're gonna do is explore how to get. So I noticed that in this case, the orange polynomial is basically replaced with the black one based on this equation. So how did this student get it? Well, it looks like they put x minus 1.464 for this one, and then x minus 1.5 to maybe, get really, really close between the two. So this one looks like it still has 3 x-intercepts, or, and here we're looking for 2. So is there someone that truly has 2? I think this one here. So this student did get 2 x-intercepts, 1 here and 1 here, which is 2 roots. But this actually is called, this is actually three roots. This is a double root. And so, if we instead wrote this, if we wanted to repeat this other one, instead of the x minus 2 factor repeating, what if we repeated the 1.464 factor? Would we still have 2 roots? Let's see. Okay, I don't see it. Let me see if I could try another one. Let's try this one. So this is pretty close. This just needs to be x plus 1.464. And then x minus 2 is good. Let's add this other one and see. Okay, cool. So notice that the if I wrote the x plus 1.464 twice, notice what it does here. It basically doesn't match the orange one, but it basically hits. It has 2 x-intercepts still, because these are the same. So this hits the x-axis twice, but in a so the main thing I want to emphasize with this activity is, yes, the x-intercepts and factors are going to be, kind of talking about the same thing, roots and x-intercepts. But notice there's 3. This is 3 roots, or this is a double root, and this is a single root. So really, there's 3 roots, but only 2 x-intercepts. Now, how would you describe this x-intercept versus this one? Well, if you look at this part here, you can see this polynomial just goes through. But if you look at this one here, it doesn't go through, because it would come out the other side on the bottom, but it looks like it bounces off of it. So this x-intercept is a bounce, okay? And this x-intercept is passing through. All right, so that's basically a good way to separate those two. Now, this has a double root. There's 2 of them, x minus 3, x minus 3, then another factor and another one. So there's actually 4 roots. 4 roots here. And so to get the 4 is correct. So 1 is squared. Yes, there's 2 corresponding roots to x minus 3. Good. Now, if you pick 3, that's not a bad thing because I've been telling you roots and x-intercepts mean the same thing. So if you see, if you look at this graph, you'll see 1, 1, 2, 3 x-intercepts. So why not think of 3 roots? But notice that this one here is written twice. Technically, x minus 3 is the same thing as x minus 3 squared. But notice it passes through here because there's a single factor there. It passes through here from the bottom up because there's a single factor here. But notice right here at 3, it bounces. And the reason why is because there's a double root there. You're going to get more notes on that later. But the last thing I want to talk about is is this. So all of these parabolas are not touching the x-axis. So technically, there's no x-intercept. So is it possible to write it as factors, knowing that factors give you the x-intercepts? Well, no, it's not possible to write the factors because there's no x-intercepts. The only way that you can actually write a parabola, a quadratic equation like this with no x-intercepts is in standard form. So I did see somebody write that. I saw that answer here. It's not possible to use these factors, but it is possible to write it like this. This is really, really advanced. Whoever wrote this, I would just include the A. But yeah, this is really, really good. You just cannot factor it. And so there's no x-intercepts. Now, this leads to something really, really exciting. I wanted to just show as the last thing for this video. And so, notice something like this. Whenever you factored, right? Anytime you factored something quadratic, you would get x plus x minus something, right? And so, if you factored this one, for example, x squared minus 4, you would get 2 factors, x minus 2 and x plus 2, and that would be difference of squares, right? So you could see that the red and the green parabolas are the same. These are equivalent. This is just in standard form. This is in factored form. So notice the factors still give you the x-intercepts. And that was the point of factoring it, to see the graph. But notice this now. There was two x-intercepts, 2 factors before. Now there's 1 x-intercept. This is actually a double root, right? X squared. That's kind of like if you would have x, x minus 0 squared, if you want to call it. That is a double root. So, there's 2 roots here. There's 2 roots there. There were 2 roots here. So these are 2 roots. These are real. You can see them. This is 2 roots here. It's a double root. But notice this one. There are no root. There's no x-intercepts here. So this is when we talk about math and x-intercepts, this is a big change when you talk about roots, because if you cannot factor it, you can't find the x-intercepts. But remember what you used when you couldn't factor a quadratic? Well, you'd use the formula. So if I were to write this into the quadratic formula, there's no linear term, so I'm going to write 0x here. This isn't 0, this is 1. So 1x squared plus 0x plus 4, that's the same thing as x squared plus 4. So they're the same thing. You can kind of see that, the graphs overlap here, the red and purple. But if I write it like this, then I have my A, B, and C. So if I plug in A equals 1, B equals 0, and C equals 4, and I calculate with the quadratic formula, what I end up getting here is under the square root, I get a negative number. And what letter do you get when you have a negative square root? Well, you get an I, which is imaginary. But notice when you have a plus and minus from the quadratic formula, you get 2 solutions. You get 2 imaginary solutions. or two, and another word for solutions is roots, right? So you have two imaginary roots. And look at this. Even though this parabola does not have any x-intercepts, there's technically still two imaginary roots based on this quadratic. And so when you think of x-intercepts and roots, now there's a difference between real roots, or actual x-intercepts, and imaginary roots, are no x-intercepts, but you still get these roots from the quadratic equation, quadratic formula. And so this is basically one step toward looking at the fundamental theorem of algebra, which is really, really exciting for me because and I want to kind of show you this. Like, this is something that's going to be in the far distance a little bit, but I still want to kind of show you a glimpse that x-intercepts and roots kind of mean the same thing. Just like when you first learn a language, you kind of learn, okay, this is what it means, but then when you get older and more advanced, you say, okay, well, really, it's not that simple. There's distinctions between the words, and so yes, x-intercepts does mean real roots, but you can also have imaginary roots where you could potentially have two x-intercepts, but it just goes above the x-axis, and so now there's only two imaginary roots. All right, and that's where you get the quadratic formula coming into play. All right, well, that's the video, and I hope you're doing well.